In this video, we're going to go over some alkene reactions, and we're going to talk about Markovnikov's rule. This is a concept that you're going to have to get down in organic chemistry 1, and if you don't get it down now, it's going to haunt you in organic chemistry 2. So what's happening here? Electrons always flow in the direction of a positive charge. So anytime you look at a problem or reaction, think about where are the electrons going to flow. In this situation, we have this positively charged hydrogen. And this positively charged hydrogen is positively charged because this bromine is electronegative and is pulling the electrons towards itself. And this bromine has these lone pair of electrons and is sharing these two pair of electrons with this hydrogen, but it's tugging on these electrons in this direction. It's tugging on these, so it gives this hydrogen a positive charge. So this double bond, these two electrons here are going to be attracted to this positive charge. And as a result, what we're going to have here is a bond forming with that hydrogen. And I'll just write it in red so you can get the idea. So this hydrogen, this bond is formed here. So you have 1, 2, 3, 4 carbons. 1, 2, 3, 4 carbons. And so you have this hydrogen bound here. So what you have left over, since this carbon here lost a pair of electrons, it now has a positive charge. And you have this bromine that's now detached from this hydrogen. So what happens when these pair of electrons reach out and grab this hydrogen? This hydrogen leaves behind its electrons, and these electrons stay on the bromine. So the bromine atom is now floating around in your solution like this, which is negatively charged. And again, we're going to have a situation where these negatively charged electrons are going to be attracted to this positive charge here. And then we're going to have, and you really don't have to draw these hydrogens in for the future. Once you get used to it, but it's good to draw them at first, that way you can know what's going on. This bromine can attack this positive charge from either side, so you're going to have a mixture of products. You're going to have a product where the bromine is going to be in the front, and you're going to have a product where the bromine will be behind the plane of your paper, of however you're looking at this. So you have the bromine here. So this bromine can attack from behind. So just think about this particular molecule being in three-dimensional, and you can attack it from behind and the front, and you have to show that stereochemistry. So really you'll have a mixture of these two products here, where the bromine is in the front and the bromine is in behind. And the Markovnikov rule, you can remember it like so. The halogen is going to go towards the carbon that has the least number of hydrogens, and the hydrogen is going to go towards the carbon that has the most number of hydrogens. So in this particular situation, the hydrogen added to the carbon that already had 2 hydrogens, and the bromine added to the carbon that only had 1 hydrogen. you can look at it this way. The bromine is going to add to the carbon, and I think this is a better way of looking at it. The bromine is going to be added to the carbon that's connected to the most other carbons. So in this situation here, we have this carbon. This carbon is connected to two other carbons, whereas this carbon here is only connected to one other carbon. And if you're not careful, you can get confused on that in other problems, especially in a situation where you have an equal number of hydrogens. For example, if we have this compound here, and you add HBr, what product would you expect to get out of this? Feel free to pause the video and think. So ask yourself, which carbon is bonded to the most other carbons? In this particular situation, you have equal number of hydrogens. And when I first learned this from my professor, he would say the hydrogen went to the carbon that had the most hydrogens. Well, if you see this on the test, you would be stumped if you just only knew that rule about Markovnikov. Both has an equal number of hydrogens across this double bond. So in my opinion, it's best to think about it in terms of stability, and stability comes when you have the most number of carbons bound to the particular carbon that you're looking at. So this carbon here in question is bound to 1, 2, 3 other carbons, and that is the carbon that the bromine is going to be attached to. So if you redraw it here, you're going to have the bromine added here. And just to show it better, I'll draw it like so. So the bromine is going to attach the carbon that's attached to the most other carbons, and the hydrogen is going to attach to the other carbon across the double bond. And just to be extra clear, if you're unsure about this, these are representations of the exact same structural formula. This is what you call a bond line notation, where you have the little stick diagram. This is the structural formula where you actually write out the carbons and the hydrogens as such. And down here at the bottom, you can add the bromine and the hydrogen like we did up here. It can also be represented like this or like this. So they are all representations of the same structural formula.